Okay, so let's start. Again, chapter 2 is focused on sampling, standardization, and calibration. So what is that all about? No? So this chapter will tell us how do we conduct analysis in the laboratory and what are the ways for us to determine the amounts of our substances in our sample solutions. No? So this will tell us how will we get samples and later on how will we do experiments with our samples. Okay, so let's start. When you are analyzing substances, y- hindi mo kailangan kumuha ng maraming substance. No? For example, you're analyzing blood. Do you need to get all the blood of that patient? Hindi, kasi mamamatay siya. For example, I analyzed the Ilog Pasig before. Do I need to collect all the water of that river? No. Okay. So that means when you are studying something, you do not need to get the entire population and get them tested. No? Hindi ganun yung ganap sa sampling. So, ang mangyayari sa atin is that we will just only get some representative uh, group from the population and sila yung magiging focus ng ating study. Okay? So, that is applicable to quantitative and qualitative researches. Let's say quantitative is yung, kunwari, blood chemistry. Hindi mo kukunin lahat ng blood. Instead, kuha ka lang ng onting blood. No? So, that's 5 ml usually, di ba? So, ganun. Kunwari, ilog Pasig yan. So, hindi mo kukunin lahat ng tubig sa ilog. Okay, so you only collect a few liters of that river water to be analyzed in the laboratory. So, kung yan ay qualitative research naman, instead of surveying all the people in this specific region, hindi mo gagawin yon. Instead, you will use the Slovene formula in order to determine what is the minimum number of people that has to be interviewed. Yun yung ginagamit ng mga surveys, no? For example, yung Pulse Asia survey, gumagamit sila ng Slovene formula. That's why their respondent is only 1,300, no? And statistically, yun lang dapat talaga yung kailangan i-interview, no? In order to represent the entire population of the Philippines. However, there are biases naman. So, alam nyo na kung bakit. I will not dive into that na. So, ganun. There are still there are biases sa research na. Pero pagdating sa chemistry, there should be no bias kasi we are dealing with numbers, no, not opinions. Okay? So, So when collecting sample, again, kuha ka lang ng onting part ng solution mo from your original source or your population, then you analyze it, no? And depending on the quantity of your sample or the concentration of your analyte, okay? So may new term tayo, analyte. What is that? When you say analyte, these are the substances with unknown concentration. So basically, sila yung hinahanap nating substances. No? Yung concentration ng substance, yun yung aalamin natin. We call them analytes kasi sila yung ina-analyze. Okay? So, yun lang. So depending on the two factors, the amount of the sample and the concentration of your analyte, there is a specific analytical method that has to be done. Okay, so one analytical method will not work for other uh, for other types of analysis because of the sample size or the concentration of your analyte. Okay, so for each amount of substance na may corresponding na may corresponding na methods for that. Okay, so hindi to one shoe fits all, no, hindi siya one method applicable to all. No, in analytical chemistry, for each methods meron siyang isang sample size na ire-represent. Okay, so if ever nakakita kayo ng cookbook, I mean, cookbook kasi tawag namin dun eh. That is a book that contains all the recipes or the methods in doing analytical techniques, no? Pag nakakita kayo nun, it will tell you what is the required amount of sample or what is the range of the concentration of analyte. It can be um, in which you can use the in which you can use the method to carry out the analysis, no. So ganun. For every type of your sample, may corresponding analysis. Okay? So punta tayo sa sample size, no. Depending on the amount of your sample, you can have different types of analysis, no. So let's say we have macro analysis. We will employ the use of macro analysis when our sample size is about zero point 0.1 and above, no, in terms of grams. Okay? So kapag medyo mabigat, no, yung ating sample size, then we can employ the macro type of analysis, no, or the macro analysis. So I'll give you some example of macro analysis. Number one will be the gravimetric analysis, no. So gravimetric analysis, yun yung gagawa ka ng chemical reaction, you will evaporate your material, so on and so forth, no? So gravimetric analysis yun. So it involves the measurement of mass, no. So pwede pa yung analytical balance dyan kasi 0.1 gram yung ating measurements. Other type of analysis could be titration or volumetric analysis. Pwede yan dun sa macro analysis. No? Kasi we are dealing with huge amount of our substance. No? When we say huge amount sa chemistry, okay na yung 0.1 gram. Malaki na yon, okay, sa chemistry. However, if our sample size decreases, then we have to adopt much sensitive techniques, no? So, hindi nagagana yung gravimetric analysis and yung volumetric analysis, no? So, that means you have to use other types of analytical methods in order to resolve your analysis, no? So, kunwari, pag konti na yung substance mo, less than 0.1 gram na siya, then you should look for methods that is applicable to semi-micro analysis. Okay. So semi-micro analysis technique is done when your sample is in the range of 0.01 to 0.1 grams. Okay. So may another methods for that. Again, ang method for macro and semi-micro, they are not always equivalent. No? Hindi sila parating same because uh, because depende sa dami ng sample natin yung technique, no? Yung technique, pwede gumana siya kapag marami sample mo, pero pag konti na yung sample mo, hindi na siya gagana. And nangyayari yun. Okay? So, ayun. For semi-micro analysis, we may not use gravimetry or titrimetry or volumetric analysis. Instead, we may need to use advanced analytical techniques such as electroanalytical methods and spectrophotometric methods. Okay, so yun. And that is applicable to the rest of the type of analysis here. So we have the micro and the ultra micro analysis. Okay. So again, ano yung point natin dito? Our point here is that for each type or for each amount of your substance, of your sample, there is a corresponding analytical method. Okay? Kasi kapag yung sample mo onte and you use the wrong analytical method, then wala kang makukuhang result. Okay? So that's why you have to use the appropriate method for your amount of substance so that you will come up with a good result. Okay? So that your analysis objectives will be fulfilled. Okay? Other than the amount of sample, we can also classify the methods using the analyte level or the amount of your analytes in your solution. Okay, so for example, you are doing major constituent analysis. So that means the analyte must be at least 1 to 100% of the entire solution volume. No? So that's a major analysis. However, if the concentration of your analyte becomes lower, then magiging ano yan, minor trace and ultra trace analysis. Okay, so ganun lang. So there are two factors to be considered when doing chemical analysis, no? Pwedeng about the sample size, okay? And pwede rin naman about the analyte level, okay? or the concentration of your analyte. Again, what is analyte? This is the substance that we are looking for sa chemical experiments natin. Ito yung mga substance na inaalam natin yung concentration or even identity. Okay? So yun, for each type of sample, there is a corresponding method for that. Okay? So yun lang yung point natin dyan. So again, going back, so when we do research, we only get samples, no? We only get the representative fraction of your entire population, and assuming that everything is homogenized, no, according to the F test, kung naalala nyo pa yung meaning nun. Okay. So, assuming that all the other variables are homogenized in your sample, then yung sample mo ay representative ng whole. Ibig sabihin, kunwari, sa Ilog Pasig, ang nakuha kong concentration ay ganito. That means that is true for the entire river. Okay? So, pwedeng ganun yung meaning. Kaya, for a certain region lang sa Pasig River. Okay? So, yun lang. So, we are getting representation so we can deduce an idea about the entire population. Di ba ganun naman yung mga nangyari kapag nagpapasurvey tayo? So, nung senior high school kayo, may research kayo, you only pick selected people, and then from whatever was given by those people, you say it for the entire population, di ba? Alright, grade 12 ABM students, tinanong mo sila about their performance sa ganito, ganyan. Kung ano sabihin ng, let's say, 20 people, yun na yung general statement nyo for the entire batch, di ba? So, ganun din dito sa chem. Okay? So, balik ulit tayo sa process ng sampling. Di ba, we identify the population. Ito yung pagkukunan mo ng substance. No? Ito yung pagkukunan mo ng sample mo. For example, sa isa kong research, yung Ilog Pasig, ang population ko would be the entire Pasig River. Okay. The next thing that I should do is to collect a gross sample. So when you say gross sample, it is a bulk material from your population. Okay. So siguro yan, mga liter lang ng solution. Ganun kasi ginawa ko eh. So ginawa namin, ako and my friends, we went sa Pasig Ferry. Tapos kinausap namin sila, baka po pwede kami mag-travel per station. Sabi naman nila, okay lang, kami lang naman pasahero. So, inikot namin yung buong Pasig River per station, which is nakakatuwa. No? Di naman siya mabaho. No? So, ganun. So, per station, we collected sample. We collected the gross sample, which is around 2 liters ata yung kinuha namin nun. Okay. And then from my gross sample, when nasa laboratory na kami, we reduced that to a laboratory sample. When you say laboratory sample, that is a fraction of your gross sample. So kumbaga nangyari, yung kinuha mo, kukunan mo pa. So kung bale, parang lumiit lalo yung volume niya. No? So kung ito 2 liters, pagdating sa laboratory, ang gagamitin mo lang dyan ay let's say 10 ml, ganun lang. So yun lang yun. So every step sa pag-analyze ng substance, mare-reduce talaga siya. We call that the sampling increments, okay? So nagbabago-bago yung amounts ng substance na i-work on mo sa lab, 'di ba? And for you to make the analysis much general, you have to make sure that your solution is homogenized, no? So that means para yung kung ano man mabasa mo dito sa yung laboratory sample that will represent this and later on the population, you should make sure that your gross sample is homogenized, no? So when you say homogenized, dapat walang particulates yan, no? So kailangan walang particulates, then kailangan malinis talaga yan. So when you do analysis, na siya, accurate yung makukuha mong results. And homogeneous, meaning that is true for all. Okay? So yan. When we are doing analysis then, we should make sure that we minimize the errors, no? So, when minimizing errors, ano ba yung meaning niyan, no? So, ibig sabihin kasi, when we are doing measurements, pwedeng makakuha tayo ng mga other particles, no, that may interfere our measurements. Okay? Kunwari, ilog Pasig. Ano ba yung mayroon sa ilog Pasig? Bukod sa mga plastic, meron din mga buha-buhangin, no? So, hindi mo pwede i-analyze yung mga yon. So, that means you have to remove them. You have to remove the particulates, no? Mga pollution, tanggalin mo sila so that the errors will be minimized, no? Para kung ano yung kailangan mo hanapin sa solution, yun yung lalabas. Okay? So there are several ways in order to minimize the errors when doing analytical methods, no? One of which is the separation. Okay. So from the word itself, separation, that means you're just going to separate the particulates from your desired substance. No? And that can be done with different techniques such as filtration, precipitation, dialysis, solvent extraction, volatilization, ion exchange, and chromatography. No? So, bigay ako ng mga common example. Filtration. Kunwari, sa Ilog Pasig, yung kinuha namin, may mga plastic talaga, no? Okay, so gagawin mo doon is that you will filter it, no, so that the plastic particles will not interfere with your chemical analysis, no. Pwede kasi sila mag-cause ng side reaction or it could block the instrument. Kapag yun bumara sa instrument na gagamitin mo, pwede masira yung instrument, okay? Pag sinabi kasing instrument sa analytical chemistry, yun yung mga malalaking analyzers, no? So, yun yung mga gas chromatography, no? Atomic absorption spectrophotometer. Pag bumara yung mga plastic na yun doon, pwede masira yung instrument. And to replace that, it will cost millions of pesos. Kaya ayaw natin mangyari yon. That's why we have to do chemical separation muna or physical separation. Okay? So, yun. Another example would be centrifugation. For example, blood analysis. Ano ba yung mga nasa blood? Diba? May red blood cell, white blood cell, plasma, other ions. Kunwari, gusto mo lang yung ions, no? And yung ions usually dissolve siya sa liquid layer, diba? So, gagawin mo, yung mga WBC, kailangan i-separate mo siya, diba? So, you're going to do filtration. Okay? Tapos, pag I mean centrifugation pala, sorry. So, kapag nag-centrifuge ka, magse-separate yung liquid into layers in which the heavier objects will be located at the bottom of your container, 'di ba? Of your centrifuge tube, and whatever is on top, yun yung mga lighter substances, no? So, doon ka kukuha ng iyong laboratory sample sa clear part, no? So, yun yung pwede mo gawin. Okay? So, yan. So, yun yung mga techniques, no, in order to minimize the errors when doing analytical methods. Okay? So, yun yung una mong gawin. After that, kunwari, you are doing analysis and you can see na ang daming interferences. When we say interferences, we are pertaining to other ions or other substances that interfere with your measurements, no? 'Di ba kunwari, aalamin mo yung element na 'to. Let's say gusto ko alamin yung potassium. Tapos yung sodium, yung magnesium, yung calcium nanggugulo ng data. Ibig sabihin, they give other signals pa, no? And that's common, no? So kunwari gusto mo alamin yung potassium. Tapos yung ibang ions sa blood, let's say sodium, no? Let's say magnesium, calcium. So nangi-interfere sila with your measurement, no? So in such cases, you can employ chemical separations. Okay? Minsan naman hindi separation ang kailangan mo doon. Minsan amplification pa nga, no? So punta tayo sa dalawang method na to. Okay. One of the techniques in order to minimize the error is the saturation method. Okay. So ano nangyayari dito? In saturation method, instead of removing your interferences, what you're doing is that you amplify the signal of your interferences so that later on you can omit them. So after omitting your interferences, you are now left with your analyte, no? Yung substance na hinahanap mo. Okay? So yun yung saturation method. Again, anong gagawin mo dyan? You will amplify your interferences in order for you to be able to distinguish the interference from the analyte. Okay? Then later on using Excel or just Calcu, pwede mo ma-deduct yung values ng interferences. So you will be left with your desired substance or your analyte. Okay? So that's the saturation method. The other method is the matrix modifier. So this is in contrast with the saturation method. Why? In saturation method, you add interferences so that they will be amplified. Later on, you can remove them from the data. For matrix, excuse me, for matrix modifiers naman, what we're doing here is that we mask our interferences. Okay? So, ano meaning ng mask? You add chemicals to your solution in which they will mask the interferences. Ibig sabihin, pag sila niran mo yung analysis, they will not be read by the instrument. Okay? So, that is done by using chelating agents. No? Chelating agents are some molecules that prevent ions from giving off signal, no, when doing chemical analysis. Okay. So, yun yung matrix modifier natin. So, itong dalawa, these two are contrasting. Again, saturation method, you amplify the signal of your interferences so you can distinguish the analyte. Sa matrix modifier, you suppress the interferences. Ibig sabihin, pinapababa mo yung signal nila so that the analyte concentration, yun lang yung makikita mo. Okay? So, baka tanungin nyo, sir, anong gagamitin namin dyan? Depende sa method. Okay? Kasi lahat ng gagawin nyo sa laboratory, may method na talaga. Okay? Kaya may cookbook, no? Para kang nagluluto lang. Hindi pwede experimental lang. Okay? Kasi sayang yung chemicals, no? Kailangan may proper steps, may proper techniques, no? So, ando na yon sa methods na yan. Kung sinabi dito sa method na to, you add this in order to suppress the ions, then matrix modification tawag doon. Okay? Next one will be dilution and matrix matching. So, ano yung difference naman nito? When we say dilution method, what happens here is that, ano ginagawa kapag dilution? You add water, di ba? So that the concentration will be decreased, no? So, ano formula nun? M1 V1 equals M2 V2. Hopefully, tapos na kayo dun, no? So, yun yung dilution method. What you're trying to do here is that you add the water to your solution so that the concentration of the interferences will become lower. Okay? So, naglalagay ka ng water para yung concentration ng interferences bumaba. Okay? Pero ang consequence nito is that yung iyong analyte, pwede ring bumaba yung concentration niya. If detectable pa rin naman, edi you can use C1V1 equals C2V2 to get the to get the original concentration of your analyte. Okay? So, ganun lang. Para magre-reverse process ka lang. So, if this is the final concentration, according to my instrument, after dilution, then I have to use M1V1 equals M2V2 to get the original concentration. And then the last one would be the matrix matching method. So what happens here is that you add matrix, you copy whatever is in your matrix. Pag sinabing matrix, yun yung overall constituent ng substance mo. Okay. So kinokopya mo lang lahat, no? So that whenever may makita kang difference sa reading, no? Pag may nakita kang difference sa reading, then you can determine the concentration of analyte from those differences. Okay? So, yun lang. So, again, ano yung ways to minimize the errors? One is separation. You filter out the particulates that may interfere with your chemical analysis, no? Okay, so yan. Uh, Pwede yung mga particles too heavy enough to be passed through capillary tubes, no? Kaya kailangan mo sila i-separate, no? Or they may cause problems when you use your instruments na, no? So that's why you really have to separate them. Okay, so separation can be done with lots of ways, no? So yan, nandyan na naman sa slide yan. And then, kapag usapang ions naman or molecules yung problema mo, you can do different techniques, no, in order to amplify or to minimize the signals of those interferences. So for saturation method, what you're doing here is that you increase the concentration of your interferences so that you can determine kung sino yung mga interference and then remove them from the measurement, no, from the actual measurement. Okay, pag natanggal mo na yung mga interferences, then you can determine the concentration of your analyte. For matrix modifier naman, what happens here is that you suppress your interferences so that they will not give off signal. Okay, so these are chemical that suppresses the interferences so they will not give off any signal. Next one is dilution method. What happens here is that when you add water, you add too much water, then the concentration of your interferences may get lower. So they will not be detected by the instrument. Pero kunwari yung analyte concentration mo bumaba din, pero detectable pa rin, you can use the dilution equation to get back to the original volume. I mean the original concentration. Okay. And then last one, we have the matrix matching, wherein you duplicate whatever is in your original solution. And then later on, if you do chemical analysis, you check kung saan may differences. Okay? Pag may nakita kang differences, you can determine the concentration of your analyte just using some equations. No. So, yan. Okay, so um, that's how we lessen errors when doing chemical analysis. So after knowing this, punta na tayo sa paano natin dina-determine yung amount ng analyte natin. Okay, how do we determine the amounts of substances we are looking for in a chemical analysis, no? So there are lots of methods, no, that can be done to do that, no? So, yun na yung last part ng discussion natin. So, punta na tayo sa standardization and calibration. So, these techniques, no, are used when we are going to determine the concentration of our analytes from our sample. So what we do here is that we do calibration. Ang meaning naman ng calibration this time is that we are trying to establish the relationship of the instrument response with the concentration of our substance. Okay? So depende kasi sa concentration ng substance, mayroong corresponding instrument response yan eh. So for example, let's look at this picture here. So on top, we have different concentration of copper solutions. Iba-iba yung concentration ng copper dyan. This one being 0 and this two being whatever it is. Okay? Pero increasing yung concentration dyan. Okay? So if you run this liquid solutions in your instrument, let's say ultraviolet visible spectrophotometer, kunwari ginamit mo yun sa UVVs, what happens there is that it checks kung ano yung instrument reading for each concentration. So kunwari, ito yung 0. Di wala siyang reading kasi wala yung copper eh. However, if you increase the concentration of copper, the instrument response should increase as well. Okay? And by doing this, we are establishing what's called the calibration curve. Okay, so this is a calibration curve. This is a curve in which the relationship of the instrument response is proportional to the concentration of your analyte. Okay, So yan. Again, ano uling calibration curve? That is a function or that is a relationship between instrument response and the concentration of your analyte. Okay? So equation yan. So equation of the line ang pwede gamitin dyan. So that can be described by y equals mx plus b. Okay? So yan. Ang tawag natin dito sa solution with known concentration ay standard solution. So again, we call the solutions with known concentration the standard solution. Standard solution, known concentration. Ano yung unknown? Analyte. Okay, so pag unknown concentration, analyte. Kapag known, standard. So gagawin natin, we check the calibration curve for the standard. Then ano na susunod na gagawin? Since you established the curve already, you can now test your analyte. Kunwari, naglagay ako ng analyte ko. Then, ang basa ng instrument is ito. Kunwari, my instrument response is this one. Ano yung corresponding concentration yan? Remember that this point, let's assume that this point lies on this line, di ba? So we can use y equal mx plus b to solve for x, which is the concentration of your analyte. So kunwari, ito yung instrument response, that will be your y value. That will be your y-axis. So ang gagawin mo na lang to solve for x, no? So type mo na lang yan sa Calcu o kaya isosolve mo using Excel so that you can determine the value for x. Okay? Kung kunwari, you do another chemical analysis and then the instrument response is somewhere here. Kunwari, yan, the instrument response is somewhere there. How will you know the concentration again? Just use the equation of the line of the calibration curve. So, determine mo kung ano yung value ng y. After that, you solve for the value of x. No? Whatever the value of x, that will correspond to the concentration of your analyte. Okay? So that's how we measure the amounts of the substances we look for sa chemical analysis. No? So ganyan. The method I showed you, tawag dyan ay external standard calibration. So yung tawag dito sa ginagawa natin na to ay external standard calibration. Bakit siya naging external standard calibration? Because ang tawag dito sa solution na to, ano ulit tawag dyan? Known concentration yan, standard solution. What we do is that we create the calibration externally. Okay, so ibig sabihin, we do not add our standards in the solution. Wala kang dinagdag sa solution mo. So, ang ginagawa kapag external standard solution, external standard calibration is that you create the calibration curve outside your solution. Ibig sabihin, wala kang ginagawa sa solution mo. Gumagawa ka ng curve using external standards. Okay? So, ibig sabihin ba nun, meron po na solution na nilalagyan ng standard? Tapos ang tawag doon, internal standard calibration. Yes, may ganun. Mamaya, daanan natin. Okay? So again, emphasize ko lang, bakit naging external standard calibration to? Because this is a calibration technique in which you use external standard. Standard known concentration, external, meaning hindi mo siya nilagay sa solution. Okay? So you are establishing an independent equation that describes the instrument response with the concentration of your substance. Okay? So yun. Yun yung major difference niya. Siya ay ginagawa muna before you do the chemical analysis. Gagawa ka muna ng calibration curve before you can start analyzing your substance. And ito yung pinakamadali. Okay? Kasi madali lang talaga yung gawin kasi wala tayo sa lab kaya hindi ko ma-emphasize kung gaano siya kadali. So ganun, basta madali yan. Okay, so again, our calibration curve, ito yun, that is an equation in which the plot of the instrument response versus the concentration of your analyte is shown na. And then, since ito ay equation of line, we can use the different properties of line such as the slope, the intercept, and the slope. No? Ano ba yung sinabi ko? Such as the slope, the intercept, and inulit ko pala yung slope kanina. Basta yun. So, yun yung mga two properties na pwede natin gamitin when interpreting data for our calibration curve. Okay? So, yan. So, yan. So, we're done with the external standard calibration. Ngayon naman, let's go with the counterpart, the internal standard methods. Okay? Ano yung difference niya? Pag external standard methods, you are not adding standard solution in your sample. Kumbaga, you create your calibration curve without adding the standards in your solution. Kaya external standard. Pag internal standard solution, what we're doing here is that we add the standard solution in our sample. Okay? So, idadagdag mo yung standard sa iyong sample. So, para saan? Okay. Ganito. That is to improve the calibration curve. Kasi suppose if you do the experiment by just detecting one substance tapos pangit yung linearity niya. When I say pangit yung linearity, the R square is not high. Ang acceptable kasi dito sa amin is 0.9995. Okay na yan, acceptable na yan. Suppose yan ay 0.98 something. Pangit yung curve mo na yan kahit nag-external standard ka dyan. So, kung pangit yung iyong calibration curve, then you may want to do internal standard methods. So, how it is done? What you're going to do is that from your solution, you will add certain concentration of your known solution, of your standard. Then, you will check the instrument response per solution na may known concentration ng internal standard. Okay, so ito yung isang example. Yung analyte natin, iba-iba yung concentration, pero yung internal standard, fix yung kanyang concentration. So what's next is that you are going to compare the ratio of the signals, and from the ratio of the signal, you can get much better results. No? For example, itong nasa baba na graph na ito, this is when you use the ratio of your analyte and the internal standard. So yung analyte is yung sodium, yung lithium, this is the internal standard na dinagdag sa solution. So by adding the internal standard, we established better equation of the line. So that means better measurement of the amounts of matter in there, no? So ganun lang gagawin natin. So yun. So again, kapag yung external calibration mo pangit, tapos inulit mo, pangit pa rin siya. So umulit ka ulit ng calibration, pangit pa rin, then you may need to use the internal standard. So the purpose is to improve the calibration curve. No? So what happens with internal standard addition? What happens is that you will add your analytes with the solution, standard solution. So pag pinag-add mo yon, then you get the ratio of the signal ng analyte and the standard. So kunin mo lang yung ratio nila. So you can establish a better curve na. Mas maganda yung magiging curve mo. And the last technique for determining the concentration of our analyte in the solution is called the standard addition. So standard addition, from the word standard meaning known concentration, addition, ibig sabihin idadagdag mo siya. Pero compared with the internal standard method, 'di ba sa internal standard method gagawa ka pa rin ng equation of the line. For standard addition, you do not have to create the calibration curve. Hindi na kailangan. Ano na lang kailangan dito? Ratio and proportion. So for example, tawag din pala dito ay spiking. Spike meaning magdadagdag ka ng known concentration. So, ibig sabihin nun, tataas yung instrument reading kasi nagdagdag ka ng known concentration. So, spike, tumaas yung reading. Okay? So, for example, we have this solution here. We have two solutions, the unknown and the stock solution or the standard solution. So, gagawin mo muna, you will get a portion of your unknown. Lalagay mo siya sa isang flask. Then, you fill it up to mark. Then, later on, you will get the same amount of your solution. However, you will add certain amounts of your stock solution, of your standard solution, and then you will dilute it. So, ano sa tingin yung mangyayari sa concentration ng analyte dito? So, tataas when you add your stock solution for the analyte. No? So, depending on how much the response increased, no, you can solve for the concentration using ratio and proportion. Okay, kasi proportional yung increase with the concentration. Okay, so ganun lang. So ano ulit ginagawa? You get a portion of your unknown solution, you fill it up to mark, then you determine the response for this for this container. And you do the same for the other vol flask. You get the same amount of this unknown solution, you get a stock solution, then increase the volume up to mark, and then you check the instrument response. Kung gaano kalaki yung changes nila, then you can solve for the original concentration of your unknown solution. So, ang mga equations na ginagamit namin dyan is the dilution formula, M1V1 equals M2V2, and pwede rin yung ratio and proportion. No? We established those equations, which is similar din sa dilution equation. Okay? So, ganun lang. So, that's how we measure the amounts of the substance in our samples. No? So, there are three methods in order for us to determine their amounts. One is the external standard calibration. When you say external standard calibration, you are doing or you are creating calibration curve from your external standards. That means, yung standard, hindi mo siya idadagdag sa solution. So, i-read mo siya, then ipa-plot mo siya sa Excel, and then whatever the equation of the line is, yun yung gagamitin mo to determine the concentration of your unknown. Okay? Mag-extrapolate ka ng data. So, yan yung external standard calibration. Pag sinabi naman natin internal standard method, what happens here is that you add your standard in your sample. Okay, so the purpose is to improve your calibration curve and to improve the reading of your analyte. Okay, so ilalagay mo yung standard mo sa solution, and then you will get the ratio of your analyte and the internal standard, and then pag kinuha mo yung ratio nila, that will actually improve your data. Okay, so effective talaga yung internal standard pag pangit yung calibration curve mo. So yun. So magiging maganda yung yung inyong linearity. Hence, pwede ka na mag-continue with your analysis. Okay? And then the last one that doesn't generally require calibration curve is the standard addition. So what happens here is that you read the measurement for your unknown, and then you add another amount of your stock solution or your standard solution to your unknown to change the reading ng instrument. No? So by adding the stock solution or by adding the standard solution, the reading for this solution now will increase. By just determining how much the readings increased from this to this, pwede mo makuha yung concentration. Okay? You can use the dilution formula to measure that. However, di na natin gagawin yan kasi BS Chem yung usual gumagawa niyan. So, concept lang yung okay sa atin. Pag ginawa niyo yan, maiiyak ka kasi kasi ang daming equations din na involved dyan. Okay? Tsaka one sem lang tayo. Yeah. Ito yung reason bakit tatlong sem yung Anachem sa BS Chem. No? Ito, standard addition method. Isang week namin yan dinidiscuss dati. Ganun katagal yung discussions dyan. Dami equations eh. Okay, so malapit na tayo matapos. Lastly, since we established the calibration curve, we should also check whether our calibration curve is good or not. No? Paano? By using the figures of merit. No? Check natin kung okay yung ating calibration curve for our type of analysis. No? So, figures of merit for analytical method tells us whether our calibration is sensitive no, or not, kung ano yung kanyang lower limit, ano yung kanyang upper limit, no? So that when we do chemical analysis, tapos pasok siya dun sa ating sa capability ng ating calibration curve, then we will get accurate results. Kasi anything beyond the calibration curve, any measurements beyond that, magiging unreliable na yung measurement mo. Okay? So again, figures of merit, ito yung data that we check so that malalaman natin if our calibration curve is good at measuring concentration of our substance depending on its sensitivity, the lower and the upper limit of your calibration curve, no? And other stuff, no? Such as yung precision niya and accuracy. So, yun. So pag-usapan natin yung calibration sensitivity. How will we know if our calibration curve is sensitive? By just looking at the slope. Yun lang yung sagot doon. So there are three types of slopes that we will encounter in Anachem. There is a very steep slope, the normal slope. When I say normal slope, yun yung around 45-degree angle. And then we have a very low slope, no, which is less than the 45-degree angle. Okay, some of the calibration curve are good when it is very steep. Minsan good siya kapag very steep siya. However, sometimes hindi. Sometimes naman, ito yung optimum. Ito yung best. Pero ito, this is not usually used. Okay? Explain natin bakit. No? Remember that this line can be expressed by the slope, di ba? If masyadong mataas yung slope, then that means your calibration curve is sensitive. Saan siya applicable? Sensitive calibration curves can be used when determining the trace and the ultra-trace constituents in your sample. Okay? Kaya nga, pinag-usapan natin yun nung una, di ba? So, pwede mo ito magamit when you are measuring trace and ultra-trace analysis. No? Kasi onti lang yung gap no, ng concentrations doon. Hence, the calibration curve must be sensitive enough no, in order to read those gaps very well. Okay? However, if you are analyzing minor and major constituents of your sample, then hindi na to pwede. Bakit? Lalagpas ka na sa curve na yan eh. Pwedeng lumagpas ka na. Kunwari, andito yung measurement mo, lagpas na siya. So, hindi na accurate yung mga solve mo doon. That's why you have to change your calibration curve to this one. So, paano mo babaguhin yung calibration curve? Gawa ka uli. Okay. So, kunwari, minor or major analysis ka na. Wag na yan. Gawa ka na lang ng bago. Okay? So, ito na yung bago natin. So, this is the common calibration curve. Usually, it has an angle of 45 degrees. No? And yan. This is good for micro and major analysis. No? So, yan. It could distinguish quite bigger gaps of concentration compared to this one. Kasi ito, onting changes lang sa concentration, mataas agad yung reading kasi ang taas ng slope eh. However, this one, ito, medyo flexible pa to. Okay. Itong isa naman na to, yung mababa yung slope, this is not quite good, no? If your instrument is giving you this kind of slope, no, yung mababa talaga yung slope na yan, that means that there's something wrong. No? There's something wrong with your instrument, okay? Or this is not very sensitive enough to distinguish your substances or the concentration of your substances. So kapag ganyan yung slope nyo, ulit-uli kayo. Pero kung ganyan pa rin uli yung lumabas, then you have to purchase new instrument or you have to repair your instrument. Okay? So ganun. Ang common kasi is ito and ito. Ayun, yun lang. Okay, so that's how we determine whether our calibration curve is sensitive or not. Just determine the slope now or by just looking at its angle. Tingnan mo lang yung angle niya. Okay, so for example, ito. Diba? Ito ay medyo normal lang to. Kasi yung angle niya is yung the common angle. So let's say ito 40, ito 60. Okay lang 'yun. Pero kapag yan ay naging pag ganun, kunwari yan ay naging pag ganun, that's too sensitive na. Okay. So it may work for micro analysis, I mean trace and ultra trace analysis, pero it will not work for minor and major constituent analysis. Okay. So pag ganyan yung slope mo, okay lang yan pag maliliit lang yung substances mo. Pero pag masyado nang malaki yung concentration, hindi na good yan. Better na yung ganito lang. Okay? Another figure of merit will be the detection limit and the linear dynamic range. So let's talk about detection limit. So when we are doing chemical analysis, may limit yan. We have the lower limit and the upper limit. No? Okay. Napunta muna tayo sa lower limit. So, I don't know if na-discuss na yung chapter 2 ng statistics sa inyo, pero doon sa chapter 2, sinabi doon na when we are doing chemical analysis, there is always error, no, for all types of measurement. Kasi yun yung nature ng statistics, no. May error talaga parate, no. That's why we use the bell curve, no, to check the confidence level for our measurements, 'di ba? So ganun din dito. So meron kasing tinatawag na standard deviation. So that means yun lang yung allowable noise, no, for the random error. If your standard deviation gets quite bigger, then that means may other types of error sa inyong measurement. For the calibration curve, what we do here is that we determine the standard calibration, the standard deviation of our calibration curve, and we set it as the detection limit or the lower limit. Bakit? Any measurements below that, any concentration below that can be regarded as noise or can be regarded as errors. So anything na mababa sa standard deviation or sa detection limit, yun ay noise na lang. Okay, so hindi siya useful data. Okay? It may agree with the equation of the line, but again, there are errors in measurements. So pwedeng error na lang yung measurement sa part na yan, sa super baba na concentration. Okay? So that's okay lang naman. Okay? Kunwari naman, if you go higher, for example, you are setting up your calibration curve, the higher your concentration becomes, your curve starts to plateau. Okay, so when we say plateau, yun yung nagfa-flat. Okay, so it starts to plateau at the end. No? Kapag tinaasan nyo yung concentration masyado, your instrument may not read higher concentrations very well. So, limited lang kasi yung capacity ng ating instruments. So, that's why you have to check kung ano yung dynamic range mo. Kung hanggang saan yung pwede mong ma-read. No? For the lower limit that is determined by the detection limit or the standard deviation, for the upper limit that is detected, that is determined by the last point in which your linear curve will have high Poisson coefficient or will have high R square. Okay? So hanapin mo kung ano yung last point kung saan mataas yung R square mo. Kasi once your data point starts to deviate from linearity, then your R square will decrease. Hence, your fitness of the line will decrease. No? Ibig sabihin, pangit yung curve mo pag ganun. So ano po yung fitness of the line? Yun yung R square or the Pearson correlation coefficient. Naalala nyo pa ba yan sa stats nyo nung senior high? Ayan. Gulat kayo, may stats na. Ngayon, stats talaga ta. So, kapag masyadong mababa na yung Pearson coefficient mo, then that means there is a low correlation between the instrument response and your concentration. And we don't like that. Gusto natin there is a high correlation because we are assuming that the function is linear. So once na mag-parabolic na yan, yung points na nag-deviate from your linearity, you must omit them. Okay? So, tatanggalin mo na sila so that you will establish a very good calibration curve. Okay? So, kung nasaan yung dulo, okay? So, hanggang dun lang yung dynamic range. Anything beyond that is not good na. So, kailangan when doing measurement, somewhere in between ka lang. Okay? So yun. So even calibration curves has its own limits now. And those limits are determined by statistics now. So that's why in your chapter 2 in the laboratory, you will discuss how to solve for the standard deviation and other statistical tools which you may need to determine the types of error that you have in your experiments now. Okay, so with that, we're done with our discussion for today. For now, ang bibilis lang ng discussion natin, no? For now. For now lang. Next week, we will start our um, chemical equilibrium discussion na. So, yun, medyo may solving na tayo doon. Anyway, so mag-ano lang tayo, quick recap na. Eh, ba't di na full screen? Ayan, nag-full screen na. So, let's have a quick recap of what we have discussed today. So, again, when doing chemical analysis, you only get a few portion of your population to be your sample. We call that the representative fraction of the entire population. Depending on the amount of your sample or the concentration of your analyte, there is a corresponding analytical method to solve for the amounts of your analytes. No? So depending on the sample size, may corresponding analytical method and the same as for the concentration of your analyte. No? So yan. Then what else? As you go to the lab after getting your sample size will decrease, no? So that's why it must be homogenized, no? Before you run your experiments. And also, bago din kayo mag-experiment, you make sure that you minimize the error of your uh, you must minimize the errors of your measurement, no? So, paano natin minimize yung errors sa Anachem? So, we can do separations. You filter out the unnecessary stuff that may block or may interfere your substances, no? Pero kung ang ating mga interferences ay mga molecular level o kaya ions, then you can do chemical modifications, no? Pwede ka mag-saturation, increase mo yung concentration nila, then later on, subtract mo yon so that you will be left with the analyte reading. Yung matrix modifier naman, you add those solutions so that the interferences will be suppressed. No? So whatever is read by your instrument will correspond to the analyte that you are looking for. For dilution, this is a method in which you add water to decrease the concentration of your interferences. Hence, they will not be detectable. Okay? For you to determine uh, the original concentration of your analyte, then you can use the dilution formula. And then last one is the matrix matching. You are attempting to duplicate the you're attempting to duplicate whatever is your solution, then whatever the difference is according to your measurement, then that should tell you the that should tell you the concentration of the analyte that you're looking for. Okay, In order for us to solve for the concentration of the analyte, we do the calibration. Okay, so there are, what is a calibration? A calibration is an equation of a line that determines the relationship of your instrument response with the concentration of your analyte. There are several ways to do the calibration. Una is the external standard calibration, in which you use external standards to create the standard calibration curve. So again, kapag sinabing external standard, you are not adding this solution to your sample. So you are creating the curve first before you analyze your sample. For internal addition, asan na yun? Internal standard addition or internal standard methods, what you're doing here is that you are adding internal standards in your sample so that your calibration curve will be enhanced, no? And that will give you good reading for your measurements. Okay. Ginagamit din tong internal standard when your analytes are very low, no? Kunwari naka ppm or ppb levels na. Ito yung gagawin mo. Ito yung hindi namin ginawa dati. Kasi ang ginagawa namin when we are tracing sodium levels sa ilog Pasig, yung sa lead, okay lang yung external standard. Kasi mataas yung lead level sa ilog Pasig. So, ibig sabihin nun, cancerous yung ilog Pasig. Yes. Especially nung may, Pandakan Oil Depot, sa tapat ng PUP yun. Tapos sa bandang Pasig, meron pang oil depot daw doon dati. So, yun. Yun yung reason ba't mataas yung lead because of those petroleum products, no? So ngayon tinanggal na sila, so we're expecting na bumaba yung lead doon. By the way, yun nga. So we are analyzing before yung lead contents and okay yung external standard. Pero once we try the sodium level concentration, yung calibration curve namin something like this pero pangit yung R square. Hindi namin naisip na pwede naman pala mag-internal standard. Ni-rush lang kasi namin yun eh. So ayan. Pwede naman pala mag-internal standard so that you can improve the measurement reading of your analyte when they are in very low concentration. Okay? And ito naman, if you have limited amount of your sample, you can do spiking. No? Ito yung ginagamit sa blood, for example. When you're analyzing the contents of lead in the blood, ganito daw ginagawa. I have my classmate, no, na siya yung nag-analyze ng blood sample ng students sa isang school sa Metro Manila na nag-leak yung mercury. So, hindi ko sasabihin kung anong school yan, pero alam niyo yun. So, yun. Isa siya sa mga nag-analyze kasi sa National Reference Laboratory siya sa East Avenue Medical Center. Doon siya nag-OJT. Okay. So, ginawa nila, ito, standard addition kasi onti lang samples nila. So, bale, ito yung blood solution, yung blood extract, then nag-spike sila ng lead solution, then they compared the concentrations, and then later on, by using ratio and proportion, they determined that this person has this amount of lead, and yun. So, ayoko na sabihin yung results. Confidential eh. So, yun. Pero alam ko, no? So, yun. So, ganun yung ginagawa kapag limited yung inyong samples. Okay? So, with that, we're done with chapter 2. That means chapter 3 na next week na. Okay. So, by the way, before we end our discussion, next week there will be scheduled activities, no? Ng FEU mismo because of the founding anniversary ng FEU, no? Okay, so yan. May mga events na kailangan nyo umattend minsan, may mga events na nanonood lang kayo, especially mga banda-banda, no? So please enjoy those stuff na lang kapag may ganun schedule doon. Okay. So Wednesday and Thursday, walang regular classes ata nun because of the flare session. Okay, so flare session, alternative classes yon in which your instructors will discuss anything outside the classroom topic. So may magdi-discuss about pera, may magdi-discuss about their hobby, may discuss about iba't ibang stuff, no? Anything under the sun except lessons, okay? So alternative class nga siya. So please attend those sessions para may naman kayo matutunan other than the class setup, ha. So yun lang. Yun. So we're done with chapter 2. Okay, so expect that our quiz here will be will be identification, although multiple choice yun. And then pwede rin siyang case to case basis na. So mag-a-analyze ka ng problem. Okay? So yun. So that will be all for today. So thank you for attending our class session. Um Ayan, I'll see you around next week na lang. Na. So ingat and bye-bye. A copy of the class recording will be uploaded on YouTube. Okay? So, yan.